Karl Pearson's correlation coefficient. This is another mathematical method of finding the correlation between two or more variables, and it's usually applied to data or variables having a linear relationship. So a linear relationship, it means that when one data changes, the other data, or the other variable, sorry, when one variable changes, the other data changes by a constant amount. So when we plot the values on the graph, we get a straight line. And Karl Pearson's correlation coefficient is based on the concept of covariance. So covariance is related, or it's similar. It's not the same, but similar to correlation. The only difference is that while covariance gives us a measure of the direction of correlation, whether they are having a positive correlation or negative correlation, or a positive relationship or a negative relationship, correlation is a special case of covariance, where besides the direction of the relationship, we also get an idea of the degree of relationship. The degree in the sense that whether there's a high degree correlation, a medium correlation, a low correlation. So let us take a look at the formula for the covariance between two variables. So the covariance between x and y is equal to the sum of the deviation of x values from their mean into the sum of the deviations of x values from their mean into the deviations of y values from their mean divided by the number of pairs of observations. And this can also be written as follows. Now, Karl Pearson's correlation coefficient is based on covariance because the formula for Karl Pearson's correlation coefficient is just a slight modification of this formula. So Karl Pearson's correlation coefficient, which is denoted by R, is nothing but the covariance between x and y divided by the product of the standard deviation of x and the standard deviation of y. Now the standard deviation of x is nothing but the square root of the variance of x, and the standard deviation of y is the square root of the variance of y. So the standard deviation of x is equal to square root of the variance, which is nothing but 1 by n summation the square of the deviations of x values from their mean, which can also be written as follows. And similarly, the standard deviation of y is the square root of the variance of y summation of the square of the deviation of y values from their mean, which can also be written as follows. So we just substitute these values in this formula over here, and we get Karl Pearson's correlation coefficient, and it's equal to the covariance. So the covariance is this, which is 1 by n summation xy x bar y bar, and into the product of the standard deviation of x and the standard deviation of y. And we already know what is the standard deviation of, let us take this part here, standard deviation of x, which is 1 by n summation of the squares of the deviations of x values from their mean into the standard deviation of y. The standard deviation of y is we've already shown here, This is the standard deviation of y. So we just put that value over here. So this is how the Karl-Pearson correlation coefficient looks like. So let us take an example to understand this better, where here we have to find the Karl-Pearson correlation coefficient from the following data. We already know the formula, and we just simply have to. So for applying this formula, what we need is so use in this sum to apply this formula, what we need to find is, first of all, the mean, arithmetic mean of the x series, arithmetic mean of the y series. Then we need this value over here, summation of the product of x and y, and we need to know what is n, the number of pairs of observation. Then we need this value over here, summation of x square, and we also need this value over here, summation y square. So once we have found those values, we just substitute the values in this formula. So let us take an example. So given this data, we have to find Karl-Pearson's correlation coefficient, and we already know what the formula looks like. So let us just take down the x and y values. So x values over here, let us denote it by small x. So let us say, let small x represent x values, and small y represent y values. Okay, so let me write this below so that we have space for finding out the other values. So your x 2, 3, 4, 5, 6, 7, 8, and your y values 4, 7, 8, 9, 10, 14, 18. So first what we do is we find x square. Okay, square root of 2 is 4, square root of 3 is 9, square root of 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 64. So we add this, we get how much? 203. Then y square, so 4 square is 16, 7 is 49, 8 is 64, 81, 100, 14 square is 196, 18 square is 324. So sum, we take the sum of these values, we get 830. Let me write that properly, 830. Next we find the product of x and y, 2 into 4, 8, 3 into 7, 21, 4 into 8, 32, 5 into 9, 45, 6 into 10, 60, 7 into 14, 98, 8 into 18, 144. So we take the sum, we get 408. We add them all up together, we get 408. Next, how many pairs? N, we have to find the n value. So this is one pair, 2 and 4, another pair, 3 and 7. So we add all the pairs, we get n equal to 7. Okay, so now in this formula we already know, we've already found out what is summation xy, we already found out what is summation y square, we already found out what is summation x square, we know what is n, and we are left with finding the mean values. So the mean is nothing but summation of x of the mean, arithmetic mean of the x series is nothing but the summation of the x values divided by n, and the mean of the y series is nothing but the sum of the y values divided by n. So this value over here, summation n, okay, to find this we just simply add all of these x values together, okay, 2 3 4 5 6 7 8, and this gives us a total of 35. And your y values, add them all up together, this gives us a total of 70. So this way we can find the arithmetic mean of the x series here, which is 35 divided by 7, and this is equal to 5. And of the y series, the arithmetic mean is nothing but 70 by 7 equal to 10. So now we are left with finding out the squares of the mean value. So just simply take the square of the mean values, so which means the square of this is nothing but square of the mean value, which will give us 25, and y square, or what the square of this mean, nothing but square of this, which is equal to 100. So now we've got all the values. So we just put these values in the formula. So putting these values in the formula, where Karl-Pearson's correlation coefficient, it is the covariance of x and y, standard deviation of x, standard deviation of y, which can be represented as this. Remember, this is the square root of the variance. So we have already found out these values. We'll just substitute them in the formula. So this is 1 by 7. 1 by 7. So 1 by 7 into 408 minus 5 into multiplied 10. Then here we have the square root of, remember this is simply substituting the values we have already found or we already calculated, minus 25 into 830 minus 100. So we work this out first here. Those values separated by minus sign, we work this out first. So this gives us 408 divided by 7 minus 50. 203 divided by 7 minus 25. 830 divided by 7 minus 100. Let me write this here, save some space. So 408 divided by 7, use your calculators, you will get 58.29, subtract 50. 203 divided by 7, we get 29, and we subtract that by 25. 830 divided by 7, it gives us 118.57, and we subtract that by 100. So this gives us 8.29. Remember, I've used the calculator, hence I'm just simply putting the values down. The value of 4, we have to find the square root of that, and the difference between 118.57 and 100 is 18.57. So this is equal to 8.29. Square root of 4 is 2. Square root of 18.57 is 4.31, and this gives us the value of 8.29, 8.62. So your R value will be equal to positive 0.96. So that is how we find Karl Pearson's correlation coefficient.